Welcome you all to the Arduino Tinkercad simulation video session. Today we are going to see a basic LED circuit along with LED blink. Stay tuned and follow the instructions to learn the simulation software faster. Let's begin. This is a Tinkercad simulation software, and you can see on the right hand side there are a lot of components over here which you can select. I'll just drag and you'll be able to see a lot of components are available for making the set. Right, there are different types of components. Again, one you can either select basic or you can select all, so that you can get a complicated component. This is a code area and this is a simulation button for simulate. Let's start with by selecting an Arduino and a breadboard. This is the Arduino. Let's drag and drop on the workspace. So that is Arduino. Now let us drag and drop our breadboard. Right, the breadboard is also in its place. Okay, as I've told you, we are going to develop an LED circuit, basic LED circuit with a resistor, of course, and we will check LED blink along with that. So we will develop a program and I'll be giving you detailed explanation on the program, and we will see the simulated view. Right, let us first understand about the breadboard before connecting any components onto it. So there are few things which we have got to have an understanding about breadboard before connecting any component to it. I'll just give you a few examples. Like you can see over here, when you put your cursor near to the breadboard holes, it darkens and a red square comes into picture, and you can see a green light glowing throughout the line. So similarly over here, a green light glowing throughout the line. So what does that indicate is all those points which you can see over here, a red line and a green dotted line which is extended, all those points remains the same point. What does that mean? Let us try connecting lines. So when I go over a particular dot or a hole, it shows me a red square. So I can click over that. So when I click, a line comes in picture. Normally, basically by default it will be a green line. I can drag it to any other point so that it gets connected. So when I click to the other end, it forms a line, and it pops up and asks you whether you want a green line or some other line. Here I will drop down and then I will select a red line. So that is one of the line. Let me draw another line. So again you can see that there is a red box over there. I can click on, can drag and drop and select to the other point, and this I would give a black color. So two more lines I will draw from here on this point, and I will connect it here. Let it be green, and from this point I would connect it to this. So let both be green. So what I'm trying to tell you here is internally all these points over here are connected inside the breadboard. All the points inside are connected. That is, you can select or connect any component from there to any other place. So it all remains the same point. Similarly, this black line which I have drawn over here, it also internally is connected. All points remains the same. And again, one important point to be noted here is that this red line and the black line are not connected to each other. Right. So why I have connected a red line and a black line? Red line here, you can see over here at the side there is a plus sign and a minus sign. So always you are supposed to connect your positive terminal in any of these points in the red line, and the negative you are supposed to connect in any of the points in the black line. So that is the objective. And what about this? In the middle you can see like 5 dotted points together and another 5 dotted points together. So here what I'm trying to tell is, so all these 5 points here which you can see over here are connected together internally, and again over here all these 5 points are connected internally. So similarly all other points remains connected in the same way. You can see over here when I point to a particular dot, you can see a red square and a green dotted line which comes, it indicates that all those points are the same point. You can take any component from any of those points which remains the same single point. So this is the thing which you have got to understand in this breadboard. Again you can see over here the same thing is applicable to the other side of the breadboard. You can just make it a red line, so that is red, and let me put on the other one. So this is black, right? So this is how it would look like internally. All those points which I have connected in the black line, internally it is connected to each other. and all those points which have connected to the red line internally it is connected to each other. So this is one of the important point which you have got to understand about breadboard. Okay, now I have reverted back the breadboard to its original form so that we can connect our components to the breadboard. We can also move the circuit if we want to any position as required. We can also zoom out by dragging the middle button of the mouse, and just by a left click of the mouse we can drag this your circuit to any position. Before connecting the components, let us first have a look into the schematic diagram of Arduino with LED and resistor. The picture shows a schematic diagram of the circuit which we are going to build, and in that it is very clear that we have got an LED and a resistor. Resistor, it is 220 ohm resistor, so it needn't be always the same resistor here. Resistor can be anywhere between 100 ohm to 1 kilo. Always apt resistor which is preferable is 220 ohm and 330 ohm, or might be 470 ohm. 100 ohm is also okay. Keep it in mind that you are supposed not to connect an LED without a resistor, because as per Ohm's law, V is equal to IR. If you don't have a resistor, the current will increase to a very high level, which will ensure that your LED burns out very easily. So we have got to connect a resistor in place, and that value of the resistor can be anywhere from 100 ohm to 470 ohm. So in the circuit you can see that the LED and resistor is connected to D13. Okay, before telling what is D13, this Arduino has got, let us try to understand how many digital input and output pins this Arduino has. Arduino has 14 pins, which is you can see over there on the right, D0 to D13 you can see over there. D0 and D1 normally we don't use it because it is meant for transmission and reception while communicating with the Arduino, so we don't use that. So the remaining 12 pins from D2 to D13, 12 pins are available for us to use for our application. Right, so here we are going to use D13 as our pin, which will be connected to the resistor and to the diode, and the return path must be connected to the ground. So that is about schematics. Now let us start building the circuit. So for building the circuit we need two components. One is an LED and another is a resistor. Before connecting the LED, let us try to understand an LED. LED has got two terminals. One you can see a bent one and one straight. The bent is the anode and the straight one is the cathode. So what is the difference? To an anode you have got to connect always the positive terminal, and to a cathode you have got to connect the negative terminal. That means the bent one must be connected to the positive terminal and the straight one must be connected to the negative terminal. So what is this LED all about? LED is like a one-way switch for a circuit. It allows current to flow only in one direction. So that is the sequence of LED. If you connect an LED in such a way that you try to run the current in the reverse order, it doesn't allow the current to flow. Right, now let us connect the LED and the resistor. Let me pick up on the LED and I will drag and drop at any of the buttons over here. Here you can see that yes, it is connected. Now you can see it is on the holes that it has been connected. Now we will connect a resistor. So resistor, once you select that, you must be dragging and dropping at the cathode line. You can see that that is the cathode line. You can put anywhere near to that, don't put it anywhere else. At the cathode line, just down the cathode line you have got to connect, and ensure that you are not putting resistors like this because it remains the same point. So always you have got to put it across so that it is at different points. Right, so the resistor is also in its place. Now once I have placed the resistor, it will ask me what is the value you want to put. So I'll be changing this resistor value to 220 ohm. So from kilo ohm I'll be changing to ohm, 220 ohm. So the resistor is also selected. Now we know that the diode is connected from pin number 13 of the Arduino. So this is pin number 13. You can see that when you put your cursor above pin number 13, it shows D13. So pick your line, drag towards the positive terminal. You can see over here that is the positive terminal. Let me just connect that. It is connected. So always this positive terminal must be red. So let me connect take a red line so that it becomes a red line. Yes, now you can see that the anode of the LED is connected to the positive terminal, that is directly from pin number 13 it has been connected to the anode. Now the LED is internally connected from the anode to cathode, and from the cathode it is connected to the resistor, and the resistor we have already selected 220 ohm. We have got go to complete the circuit. So how do I complete the circuit? From the resistor point, the second terminal, you can see the red square button. From there you have got to connect it to the ground. Let me see, there is a ground over here in, yes, you can see over here there is a ground in the Arduino board over here. You can connect over there. So, and which is the color you will select? Black. So that is the black color. So we have already connected now the LED and the resistor as per the schematics. Now this is not enough for the LED to glow or even blink. So we have got to write a program for that. So where do I write a program? I have got to write a program in this code section. And when you click on this code section, let me click on, it will open up a blocks. Blocks is not the normal method of programming which we use in Arduino. We use text. So how do I select that? Go to this drop down and select text. It will ask whether to continue. Continue. Yes. It will give me a default program. So that is not what I want. So I will remove the default program. And now I will add my code at this place. So let me add my code at this place. I'll give you detailed explanation on my code. Let us first put this code and then we will go and check for it's working, and then we'll come back and then I will give you explanation on the code. Okay, let the code be over there. Let me just click on the code button, then it goes out, and now you can simulate the circuit, because the code is also ready, the hardware is also ready. Now you can simulate your Arduino. So let us start simulating. You can click over this start simulator button. Let me click on the start simulator button. Okay, now it is initializing and it has started. You can see over here the LED has glowed because you have connected from the 13th pin to the LED and it is connected to the resistor. LED has gone. Let me stop the simulation. Yes, you can see that the LED is turned off. You can also see that this plugin, when I start simulation, this supply to the Arduino is being turned on. This gets pushed in, and then once it gets pushed in, it generates 5 volt in this Arduino, and it can get connected to the LED and the LED glows. So let us simulate it once more. Yes, you can see that LED is glowing. Right. So let me go back. Let us now understand the code. Okay, so in this code, I'll explain to you about this later on. Let me comment this. You can comment any line of code by putting double slash. That's how you comment. When you comment, it means that that code doesn't exist, or the Arduino doesn't consider that code. So basically you will be having, let me just comment this one also. Yes. Basically you have got two functions. One is called setup and one is called loop. Basically these are the two functions of Arduino. Setup is a function which gets executed only once. That is, Arduino goes through this loop, through this function only once in its one life cycle. That is, once it turns on, it goes only once. But loop is something which it continuously does. So once it has completed its setup function, it comes to the loop function. Loop, by the term itself, it means that it will be continuously looping into it. Inside, whatever be the program you have written into the loop, it will be getting executed continuously, one after the other. So this is the basic thing. Now let us try to understand what is that I have done here to make the LED glow. First command I have given here. Let us see it one by one. Right. So let me uncomment each of those commands. Yes, so that is the thing. First function, let us try to understand what is pin mode LED pin output. Basically it is not pin mode LED underscore pin comma output. It is normally, if you want 13th pin as the output pin, you have got to provide 13 at this point. Now for a simple program like this, if you write 13, you will be always remembering it, you also understand. But when you start using all the input and output pins, it will be very difficult for you to understand by seeing the program, like what is that for which I am using pin number 13. So to have a better understanding is what we have used this variable LED pin. So now I will replace the pin number 13 with LED pin. Yes. So that is why I have declared a variable called LED pin, so that I can use it, replace the 13 number with LED pin, so that my code becomes more readable. So that is the thing. That is why in stands for integer. What is an integer? Any numbers which is not having any decimal digit is an integer. So if I want 13 to be included, if I want LED pin as a name to be included, which which will carry an integer, I have got to declare it. So this is a declaration and initialization of the variable over here. You can see that int LED pin, LED underscore pin, that is the normal format of declaring a variable in Arduino, is equal to 13. So at any place where 13 comes, I can replace it with LED pin. So Arduino will understand internally that you have bent 13 at that particular place. So it will be both readable and also Arduino understands it much better. So let us see what is pin mode. Pin mode stands for that a particular pin, as I've told you, there are 12 pins which can be used by the user. So each pin has got two properties. One is input or output. So either you can use it as input pin or as output pin. So you have got to tell the Arduino whether you are using it as input or output pin. If you are using as an output pin, then you have got to configure it as an output pin. So to configure, this is the function used. Pin mode is the function used to configure a particular pin. And this normally you have got to write inside the function setup. Yes. So to configure LED pin. So pin number 13, you are going to use it as an output. This command you are giving it to the Arduino, telling that yes, I'm going to use pin number 13 as an output pin. So that is the command, pin mode LED pin output. Semicolon stands for the end of that particular line. Arduino understands with the semicolon that particular line, the command is over and it has got to execute the next command. So that is the first function. The next, it is digital write. What does that mean? This, as I've told you, it is continuously looping, continuously doing it. Digital write means, of course, now you have selected pin number 13 as an output pin, but what is that you have got to send it to that output? It is a digital write wherein which I will be sending either 0 or 1, either low value or high value. So what is that you are going to send? Is it high value or low value? This you have got to define over here. So that is what it is written, digital write, pin number 13, make it high. So when you make it high, only then your LED glows. So that is the thing. Now this, again, as I've told you, semicolon is used to show the end of a command, and this double line, you can see double slash, whatever you write after double slash, it is a comment for us as a programmer to understand about that particular function. So you can see at every place I have put a comment. At every major important functions declaring a variables, I have put a comment to have a clarity about that part of the program. So these are the basic things which are required for developing your first code. Now let us make modification in our code to make the LED blink. So press enter over here, and then I will write the instruction delay. That is the instruction for providing a delay of 1 second. Right. For blinking, we have got to make the digital pin high and low. That is required for it to blink. So we can see over here. So I have made first high and the second time I will make it low so that I can turn off the LED pin. Right. So that is the instruction for making the LED blink. So you can see what is that I have added. I have added a delay of 1 second. So this means you can comment over the delay of 1 second. Right. So I have given a delay of 1 second so that we will be able to understand that LED is blinking. So we need a delay of always at least more than 100 milliseconds for our eyes to understand that yes, there is a change. So we have kept a 1 second delay so that it is appropriate for us to understand a blink. After the delay, I have made that LED pin low, and again after a delay it will come back to make it high. So this gets repeated because it is in a loop. So now let us see how things were in this condition. Let me take out the code from here. Yes. So now I'll simulate it again so to see what is going to happen. Yes. You can see that now the LED started blinking every 1 second. So it turns on for 1 second, it turns off for 1 second. So this is what is happening. That is the end of this video session. Hope all of you have enjoyed watching this video. Hope to meet in my next video. All the best for your online learning sessions. Thank you.